Redox method. In order to balance equations, we have several methods, and one of it is the redox method. It is also called as the oxidation number method. It is based on the principle that at any redox reaction, the total number of electrons that are lost by one element must be equal to the total number of electrons that are gained by another element. In order to discuss this method, there are some important rules that we have to discuss first. First of all, you should know what is the oxidation number. Oxidation number or oxidation state is an apparent charge, positive or negative, which an element would have in a compound. Number one rule is that the oxidation number of all the atoms in their standard state is always zero. For example, oxygen exists in the form of oxygen molecule. Hydrogen in the form of its molecule, nitrogen, sulfur, etc., all in the form of their atoms, they exist in their standard state. Number two, oxidation number of hydrogen atom in common is +1. However, in hydrides, it's always -1. Number three, oxidation number of oxygen atom in common is -2, whereas in peroxides is -1. And in OF2 molecule is +2. Number 4, oxidation number of an element in a compound is always 0. Number 5, oxidation number of ions is either positive or negative charge. Moving on, in order to explain the redox method, we have an example of this equation. Zinc plus nitric acid, HNO3, is equals to zinc nitrate plus nitric oxide plus water. The first step is to assign oxidation number to all the atoms that are involved in the equation. For instance, here we have zinc. Since it is in its standard state, so it will be a 0. We have hydrogen in common, that's +1. And oxygen, since we know that's -2. And since we have 3 atoms, so it's 3 into -2, that's -6. Since we don't know the oxidation number of nitrogen, so we can find out the oxidation number of nitrogen by applying this formula. That is basically the sum of all the oxidation number will be equals to 0 because it is a molecule. So +1 plus x plus 3 into -2, that is 0. So x minus 5 will be a 0, and ultimately x will be equals to +5. That is the oxidation number of nitrogen. Moving on to the product side, zinc in its standard state, it is +2, and the nitrate ion, it will have a sign of -2, that is its oxidation number. So this whole nitrate ion having an oxidation number of -2, we can apply this formula in order to find the oxidation number of nitrogen in this ion. So we will have a +5 for this. Moving on, for nitric oxide, nitrogen will have +2 because oxygen has an oxidation number of -2, and so the whole molecule will have a 0 oxidation number. So +2 and -2, that will be a 0. Similarly, for water, we have hydrogen. Oxidation number of its atom is +1, whereas since there are 2 atoms, so 2 into +1, and then -2 for oxygen atom, which is also equal to 0. Moving on to the step 2, we have to identify the elements that are undergoing a change in the oxidation number. Since, as we can see here, that there is only 1 nitrogen in the reactant side, however, there are 2 nitrogen atoms in the product side, so we'll just add another HNO3 for our convenience, which we will work with at later on. You can also do this for any other equation that does not have the atoms, for example, if nitrogen, sulfur, or any other atom that is not equal on both sides. This equation we will work with only in the last step, so let's just move on to step 2. In this, basically, as you can see here, that zinc, basically, it has an oxidation number of 0 in the reactant side. However, in the product side, it's +2. That is basically in zinc nitrate. The second thing is basically of the nitrogen atom. We have just added another HNO3, so we can consider that HNO3 as to produce no change in the nitrogen atom's oxidation number in zinc nitrate. However, since we see that there is an oxidation number change in nitric oxide from HNO3, so we will see that and we will have basically plus 5 into plus 2 and we will work with these numbers. The step number 3 is to draw a bridge between the same atoms whose oxidation number is changed. Indicate this change by the number of electrons lost or gained by each element. As we have already discussed that zinc and nitrogen, they undergo a change in their oxidation number. So we will have this formula that is basically reactants charge minus the products charge. And so we have zinc, oxidation number 0 in the reactant side, and we have zinc in the product side, that is plus 2. So 0 minus plus 2, that will be minus 2 electrons. And thereby, if we're removing 2 electrons, that means here we have the process of oxidation. Whereas for nitrogen atom, we're going from plus 5 to plus 2, that is 5 minus 2, that's plus 3 electrons. Addition of electrons, that is basically reduction. Moving on to the fourth step, we have to equalize the number of electrons lost and gained by multiplying the two numbers by a small whole number to produce a common number. Use this multiple as coefficient of their respective substances. For instance, we have 2 and we have 3. So a common number that basically will be 6. 2 into 3, that's also 6, and 3 into 2, that's also 6. So we'll just multiply zinc and zinc nitrate by 3, whereas nitric acid, that is HNO3, and nitric oxide by 2. Thereby, the final equation of step 4 will be 3 zinc plus 2 nitric acid plus 3 zinc nitrate plus 2 nitric oxide plus water. Moving on to the fifth step, we have to balance the rest of the equation by inspection method. What is the inspection method? The first step of inspection method is to balance atoms other than oxygen and hydrogen. Number 2 is to balance the oxygen atoms, and number 3 is to balance the hydrogen atoms. Thereby, if we see we have 4 atoms in both reactants and product side: zinc, hydrogen, nitrogen, and oxygen. Before balancing, we have 3 zinc atoms, 3 hydrogen atoms, 3 nitrogen, and 9 oxygen atoms. However, in the product side, we have 3 zinc atoms, that is basically zinc is balanced already, whereas we have 2 hydrogen atoms only, and we have 8 nitrogen atoms and 21 oxygen atoms. So in this step, what we're going to do is we have to balance the hydrogen, the nitrogen, and the oxygen. In order to do that, I have to follow the inspection method. That is, number 1, to balance the atoms other than oxygen and hydrogen. That is here, in this case, nitrogen atom. Since I have 3 nitrogen atoms in the reactant side and 8 nitrogen atoms in the product side, so if I place a 6 with HNO3, so I have 6 plus 2, that will be 8 nitrogen atoms. Thereby, nitrogen atoms are balanced. Moving on to oxygen, I have 9 oxygen atoms in the reactant side and 21 oxygen atoms in the product side. If I see here that by placing a 6, I have a change in the number of oxygen atoms in the reactant side. 6 into 3, that is 18. 18 plus 6, that is 24. Moving on to the product side, if I have to balance this 24 with 21, so if I place a 4 with H2O molecule, so that will be 20 oxygen atoms of there, and we'll have 4 oxygen atoms here, so that will be a total of 24 again. So we have oxygen atom balance, and let's just see the equation first. That if we have 4 hydrogen atom, we have 6 plus 2, 8 here in the reactant side, and we also have 4 into 2, that's 8 in the product side. So we don't need to balance the hydrogen atoms, right? So in this way, the hydrogen atom is also balanced. Thereby, we have our final equation, 3 zinc plus 2 HNO3 plus 6 HNO3 equals to 3 zinc nitrate plus 2 NO plus 4 H2O. That's it for today. Thank you for watching. Do subscribe, like, and share. And if you have any questions, do comment down below.